Homework 5 video 1. Now it is given that f of x is u of x minus 1 minus u of x. U of x minus u of x minus 1. U is the unit step function. F of x is given by u of y minus 1 minus u of y minus 2. Again, u is the unit step function. We need to find f of z. Now z is given by x plus y. Now there are two methods to solve this: convolution and the geometric method. First we'll start with the convolution. Now the formula for using the convolution method is given by f of z is equal to f of x of z convol f of y of z. Now applying the limits and substituting the values, substituting z in place of f of x and z minus alpha in place of f of y, we get limit minus infinity to infinity u of alpha minus u of alpha minus 1, that is f of alpha in terms of x, and we get f of alpha into f of alpha into f of z minus alpha. This is terms of x, this is in terms of y, minus infinity to infinity. We get u of alpha into u of alpha minus 1, minus sign in between, into u of alpha minus 1, z minus alpha minus 1 minus u of z minus alpha minus 2. Now simplifying these equations, we get four different values: minus infinity to infinity u of alpha into u of z minus alpha minus 1 minus u of alpha minus 1 into u of z minus alpha minus 1 minus u of z minus alpha minus 1 into u of alpha minus 1 minus u of z minus alpha minus 2 into minus u of alpha minus 1. So the minus sign gets cancelled out and turns into a plus sign, u of u of alpha minus 1. Now for unit step function, u of 0 is given by 1, so we can apply the following limits, that is 0 to z minus 1 to the first two equations and 0 to z minus 2 to the equations that are given below. I have already done it, and after simplification we get the answer z minus 1 into u of z minus 1 minus 2 z minus 2 u of z minus 2 plus z minus 1 z minus 3 into u of z minus 3. From this we can plot the graph of f of z, which is given by 0 1 2 3. Now for all values less than 1, the answer will be 0. You can check it out by putting the values in the equation which is given right over here, and for values greater than 1 we can easily find out that it's a ramp function, and from 2 it decreases up till 3, and finding the values at 3, they are 0. So this is the graph of f of z. This was solving by convolution method and we've solved it. Now solving by the geometric method. For the geometric approach, we first find capital F of z, which is given by p of z minus. Now we already know that z is x plus y, so writing it down in the equation, we get x plus y is less than or equal to small z. Now there are basically three cases that can occur. First is if z is less than 2. If z is less than 2, then it lies inside the square, which I have shown right over here, and then we can find it out. We can find the equation, which is given by z square by 2. Now for values between 2 and 3, z lies between 2 and 3, that is z is greater than or equal to 2 and less than or equal to 3. It will lie slightly outside the square, intersects the square, and it is given by, on integration we can find out that the value is given by minus z plus 3. And similarly for the third point, which is greater than 3, for all values greater than 3, we can easily find out that the answer will be 0. And so we can plot the graph. On plotting the graph, we get the same answer as we had got by using the convolution method, which is this, and thus we found f of z using the geometric method, which is this one, and the convolution method, which we did earlier. So this is it. Thank you.